To solve an exponential equation where I have exponential expressions on both sides, what I'd really like to do is get both sides in terms of the same base, so that at that point I can use the fact that exponential functions are one-to-one and say if the bases are the same and the expressions are equal, then the exponents also have to be the same. That's my goal here. So I'd like to rewrite 4 as 8 to a power. 4 is 8. 8 to what power gives me 4? I have no idea. 4 times 2 is 8, but that's not 8 to a power. That's just multiplication. Maybe I could do it the other way. Say 8 is 4 raised to a power. Well, the same problem. I can multiply 4 or I can divide 8, but not really an easy thing to do with exponents necessarily. So what we can do when this happens is we can outsource and look for a third-party provider that I could use to write both 4 and 8 in terms of. And here, 2 is going to do the trick. I can rewrite 4 as 2 to the second power, and I can rewrite 8 as 2 to the third power. So I can rewrite both 4 and 8 using 2 as a base. Can't really change the 4 to an 8, can't really change the 4 can't really change the 8 to a 4, but I can change both of them to 2. So that's what I'm going to do. Over here in my equation, I'm going to write, instead of 8, 8 is 2 to the third power. So 2 to the third power to the 1 minus x. That still says 8 to the 1 minus x. It just says it in a slightly more complicated way. It's the opposite of simplifying, I guess. And 4 is 2 to the second power. So I still have 4 to the x plus 2. But now, good news, I have the same base for both of them. Well, let's see. 2 to the third to the 1 minus x. If I have something to a power to another power, I'm going to simplify by multiplying the powers together. So this is 2 to the 3 times 1 minus x. Those parentheses are critically important. We need them. On the other side of the equal sign, same idea. This is 2 to the, I'm going to multiply my exponents, 2 times x plus 2. Well, now I can go ahead and use the fact that exponential functions are one-to-one. Every y has one x, every x has one y. So the only way that this statement can be true is if the exponents are the same. Since the bases are the same, the exponents must be the same too. I'll go ahead and distribute as I do this. 3 times 1 minus 3 times x is the exponent on the left. The exponent on the right, 2 times x plus 2 times 2. Once I do that, I have a nice little linear equation. We know what to do with those. I'm going to go ahead and I'm going to add 3x both sides to get all of my x's to the right. And at the same time, I'm going to subtract the 4 over here so that I put all the numbers on the left side of the equal sign. So those are going to add up to 0. Those are going to add up to 0. On the left, I have negative 1. On the right, I have 5x. We'll divide by 5 both sides. And I have x equals negative 1/5. There, we did it.